Okay, hello everyone, and welcome to Simulating Manufacturing with Composites. I'm Steve Peck, the VP of Applications Engineering and Solutions here at A Priori, joined by Chris DeRosa, an application engineer in North America for A Priori. So this tech showcase is going to have roughly a 10-minute demonstration followed by some Q&A at the end. The session will be recorded. The lines are on mute. If you have any questions, please enter those into the Zoom panel. You can also, at the end of this, I'll have my email address. You can reach out to me or through the chat panel itself on the event website. You can just choose people, select my name, and schedule a meeting for this afternoon at some point with myself through the conference itself. There are some additional resources that have been provided. This is a really quick session, but there's a pretty detailed webinar that we did with Aviation Week that's available as a link on this session. There's also a video demonstration and a link to a data sheet that covers more detail about our solution for composites. So with that said, let's go ahead and quickly just have you think a little bit about a different approach. So what if for composite parts, designers could quickly assess the cost and manufacturability of a part directly from a 3D CAD model? What if you could look at alternative designs, maybe different material choices, or perhaps something as major as looking at a composite design versus a metallic equivalent using all of the other cost models available with A Priori? What if manufacturing could evaluate different routings, optimize the build process, perhaps look at a trade-off between a hand layup approach and an automated fiber placement approach? And what if you could arm sourcing with should cost information to support supplier negotiations, or from the supplier side, be able to get a build to print package of a composite design and quickly analyze that part to get to an estimate very quickly, helping you to return that package to that quote to the customer very quickly, potentially win the business because you're in early, but also make sure that you're pricing appropriately to hit your target margins. So just some things to think about, all possibilities here that will actually show you live here on this composite core panel. So we're in CATIA here with this design that is a model-based definition of a composite part. So the typical approach for any new design, composite design today, to be done in 3D, leveraging the tools, such as this one here that's been designed in FiberSim, but A Priori can also work with a composite CPD definition in CATIA, and on the NX side, a digital definition with an NX model in FiberSim. So here we have all the plies that have been defined with their material, orientation, their step value, and location in the buildup. As well as all of the cores in the part. So we have 3 honeycomb cores in this part that are sandwiched between the undercore and overcore plies. So directly within CATIA, we have the ability to send this composite part directly to A Priori for analysis. So we just launched that part with the 3D composite definition in it, and it's opening in A Priori. So here we have this part that's been pulled in, and we have the geometry that you can see here that's been pulled in. There's a few inputs. So I have this defaulting to composites as the process group, but this is where you'd specify the high-level process group, such as the, whether it's stock machined or sheet metal or forged or cast or what have you. The next is the digital factory. So I have this representing a supplier factory in Southern California. We then look at the annual volume, the number of years that you're making this for, and the batch size. So here we're making 200 over 10 years in monthly batches of 16. So with those few inputs in the geometry that we pulled in directly from CATIA, we can go ahead and analyze this part. And we're doing a couple of things here. You can see down the bottom, it says it's getting geometric cost drivers. The geometric cost drivers on this part are all of the plies as well as the pieces of core in the design that we're analyzing. So within a matter of a few seconds here, we've gone through and analyzed the design We're looking at all of the different plies. You can see that we've got some full body plies, some undercore plies, some plies over the core that are going through over the ramps there, as well as some picture frame plies that have been cut out around the core. So quickly pulling in all the definition from that model-based CATIA design. And for each of these plies, we're looking at the surface area, all the geometric information, the perimeter, which will affect the cut time, for example, and have an influence on the layup time, the material, its orientation, and information about the complexity. So curvature information, an understanding of how much cutout each ply has, all of that that's going into the manufacturing simulation to evaluate the part. In addition to the cores themselves. So we have the 3 pieces of aramid core in this design where we understand the geometric aspects of that so that we can properly simulate the cutting of the material and placement of those parts. So if we just take a quick look at the cost summary, we can see that we quickly returned a high-level breakdown of this part. And that was actually derived at by looking at not only the material usage in the part, but also the manufacturing process. So we've simulated for this hand layup process, the cutting process, the mold prep steps, your layup process, which includes 8 different cycles where we have debulk operations at every 3 plies that are going down. The curing in the autoclave that's taking material characteristics such as the cure temp and the ramp up and the ramp down time all into consideration, and so forth, all the way through to your post-cure machining on the part and the countersinking of the holes, the trimming of the plies themselves, as well as testing and inspection, such as your C-scan inspections, and your final processes in terms of the masking and painting of the part. So that full manufacturing simulation has come into play when looking at the overall cost of this. So we've estimated $2,500 for this part, as well as the tooling cost for this part derived from the part itself. So $59,000 worth of tooling on the part. If we want to look at some additional details here, we can go over and just see some properties of the part. So it's a 15-pound part, 8 feet long, 2 feet wide, 2 inches thick, and a quick graphical view showing me where the cost is coming from. So in this case here, 45% of the cost of this part is coming from material itself. So if perhaps there's a cost down initiative, that points me to where the big hitters are, where I could have the biggest impact. So you can see from that perspective. And since we simulated the manufacturing process, we can quickly look at the cost from a manufacturing process standpoint. So here we can see hand layup is accounting for 50% of the cost, the manufacturing cost for the part, whereas curing in the autoclave at 16%, our time on the 5-axis mill for trimming and drilling and core cutting is 14%, and then your painting operations at 10%. So within a matter of seconds, really getting to a very high level of information on this design. And that can only get, you could drill in even deeper. Perhaps I get into a negotiation where I have a supplier that came back and they're at $6,000 for this part based on the design and the overall life of the part. Well, where's the discrepancy? I can start digging into details such as cycle time. So this is an overall 23-hour part, of which, cutting on the Gerber is 1.8 hours. We've got mold prep at 1.5, 5 hours of layup, 6.2 hours in the autoclave, and so forth. So you have this detailed information along with all of the equipment and the assumptions that have been made so that we can reconcile with that supplier. Why are you at 6,000, whereas, should cost on this is at 2,500? So, and perhaps as a designer, let's assume that this part had a target, for example, of $2,000. We're over by $500 on this. So what could we do? Well, we knew that we got that view that material was a 45% contributor. Perhaps there's an alternate material, it's a secondary piece of secondary structure. Stress is okay with a material change as long as we don't change the ply count. But right now we're using an 8 harness woven material. Perhaps we use a plain weave material that's a little more cost effective. What would the impact be? How much impact would that really be? And we can see here in just a matter of seconds, we'll quickly rerun the analysis, and we've actually taken a fair amount of cost out of this part. We've gotten down below the target of 2,000. We're at $1,800 for this part. So being able to quickly look at trade-offs such as that material trade-off. A manufacturing engineer may want to run an analysis that says, hey, the production volume, we just got a request to go up instead of 200 annually. Their production's beefing up, and they're thinking that they're going to need 1,000 parts a year. Does it make sense to invest in some automation for this? What would the cost look like from that standpoint? So we could evaluate those types of trade-offs as well. Or perhaps there's an alternate supplier. So we have qualified suppliers in Southern California, but another one in Wichita. So let's go ahead and take a look at running this in the digital factory of our supplier in the Midwest and see what sort of differences we have there. So again, changing some basic inputs. Actually, we've seen that, we've gone from 1803 down to 1642. So taking $160 or so additional out of the cost with the alternate supplier. Of course, you need to weigh into delivery time and quality and all of that, but giving you some visibility into the choices that you can make, whether it's from a design standpoint, a sourcing standpoint when you're working with suppliers, or manufacturing standpoint, or even from a supplier standpoint, quoting a new composite part. So very quick overview of some of the capabilities here. So, as we started this, having you think about, what ifs, well, it really is possible, as just demonstrated. Designers can quickly assess cost and manufacturability from that 3D model. You can look at alternative designs. We looked at a change in material, for example, but that could have been composite versus metallic, for example. Manufacturing, they can get some insight into the build process, where the bottlenecks are, where the big cost drivers are, optimize the build process, or maybe go through a pretty significant trade study where they're looking at, one process versus another, hand layup versus tape laying. Sourcing has the details that they need in the should cost data to effectively communicate and negotiate with their suppliers. And on the supplier side, be able to quickly analyze a bid package. So very quick overview, but it gives you a glimpse into some of the capabilities that we have for composites. If you have any questions, feel free to reach out to me directly.